A what two? Let's do testing. One. Okay. Okay, so we start. Okay. Just needed to check if it is. Just needed to check if it catches everything. Testing 1, 2, 3. Okay, I need to. Okay. But okay. Good. Okay. So last week, last recording, I ended at question 3 and highlighting about solving index equations. So now we will go through question 4 onwards. Okay, so I'll finish up the equations I have there for index, and I'll move on to the third one where we calculate the expressions and do 2 hours. That's 1.5. Let's see, I'll be able to finish it to 8 definitely. Maybe 9. 9 is easy. 10 is, I'll give 10 for another. Okay, so question 4. For question 4, the question says that if you have this 4 to the m plus 1 plus 4m minus 4m minus 1, you want to show that it can be divided by 19 for all positive integers m. So let me just enlarge it. Okay. So this will be 4. So we are starting with this thing over here, and since we quote unquote want to no matter what you do, if you see these kind of things, you basically just try to simplify it. Okay, so the idea is that if you have different things combining together, like the questions you see on the simplification ones on question on Q1, or the index equations ones on 2 and 3, and on question 2, you basically want to combine them together, right? So you just multiply become plus, divide become minus, that kind of thing, right? So then you have the other portion where you can do the reverse, where if you have minus and plus power, you can split it. So powers adding together, you can split it into multiply. Minus power, you can split it into divide. Minus power, you can split it into divide. Yeah, something like that. So what you can do is, if you see this kind of like this question 4 over here, or the ones in question 3, those type of equations, and you see the powers are there, they are doing some type of addition or subtraction, you basically want to just split them, because if you do not split them, you can't really do anything about it, right? And that's basically what we want to do. Therefore, over here, I would split this powers up. So like you see, I have 4 to the m plus 1. I will split it into 4m and 4. I split this into 4m times 4 to power of 1. For power of 1, so I don't have to write them out, so this will just stay as it is. Second term is 4 to the m. You don't have anything attached to the m power, so you just leave it alone. Minus 4 to the m minus 1, you split it into m and m n minus 1. So you have 4 to the m times 4 to the negative 1 power. So we have this. Now what you want to do is as follows. Okay, so your 4 to the 4m over here, I'll put this here, and then my 4 to the m over here. So because at the end what we'll be doing is we'll be adding the quantities of our numbers of the 4 to power m's together. What you can do is to first split them out so it's easier for you to see, and this will including splitting out the 1 that's multiplying with the 4 to the power of m, so you can write it in this particular form over here. Therefore this makes it easier to see where you use, oh, I have 4 to the 4m plus 1 for the 4m, then you can know, then you directly know that, oh, it's 4 plus 1, so it's 5, right? So this is what you want to do to make yourself clearer about it. If you don't do this, what I've seen you guys commonly get confused is that there's a plus 1 in the middle, but you don't see it because it's not written explicitly. So you ask, oh, why do we need to add a 1 to the entire thing, and then I'll be like, yeah, because the 1 over here is separated, right? It is basically 1 unit of 4 to the m. That's why you have to add a 1 to the entire total that we'll be doing later on. So anyway, the second term 4 to the power negative 1 is basically 1 over 4, and then this still stays here. So what you have is you have 4 plus 4 to the 4m. So everything is just 4 to the m, so you just treat it as like a variable or like a constant, right? So we have 4 of these plus 1 of these minus 1 over 4 of these. Okay, so you want anytime how, even if the question doesn't say can be divided by 19 blah blah blah, just simplify and add them together, right? This will basically function the same way as simplification question 1 f, right? Question 1 sub question 1 sub question f. You will basically, it's basically the same format, so we just do it anyway. So 4 plus 1 minus 1 over 4, if you get out your calculator and you press and you press this into your calculator, you will get the answer to be 19 over 4 multiplied by 4 to the m. Your 4 to the m is a constant. You can do this only because all 3 terms are in terms of 4 to the m, so they are varying numbers of 4 to the m. Yeah, so your 4 to the m will still be there because it's not this is not a fraction, you have nothing to divide it by, therefore your 4 to the m will just stay there. Yeah, if you want to see something that can be divided and cancelled out, refer back to question 1 sub question E of the simplification 1 of this worksheet. You can refer back to the previous question, yeah, and also the previous diagram, basically part 1 of this worksheet. Okay, so anyway, look at this. Since your starting equation, your starting expression, this black color one can be written as this resulting blue colored one, and you can see that this blue colored one has a 19 on top over there. So what does this mean is that if I explicitly bring the 19 down, so it just stays here, and it's supposed to be multiplying with the 1 over 4, but I just separate it out so it's easier to see. Okay, so you see the entire thing, it is a number multiplied by 19 multiplied by 4 to the m, which is basically your main unknown. Yeah, but it's also a constant. It's basically a main unknown. So you see a 19 in there within the entire multiplication. So this means that this entire thing is obviously dividing. It's obviously divisible by 19. And since it is divisible by 19, and since your end result over here is divisible by 19, this also implies that your starting expression, this black color one, this 4 to the m plus 1 and the entire thing, this is also divisible by 19. Therefore, therefore no, you just write since 1 over 4 times 19 times 4 to the m is divisible by 19, therefore your starting expression, this 4 to the m plus 1 plus 4 to the m minus 4 to the m minus 1, this is also divisible by divisible. Spelling mistake. Minus spelling mistake. I mean. Okay, so since this is divisible by 19, therefore your starting expression is also divisible by 19. Okay? Okay. Yes. Okay, audio good. Basic good, right? I just said it just now. Let me just assessment. Yep, I think it's good. Okay, let's continue. So this is question 4. Yeah. Okay, so next we have question 5. Q5 says that given that 2 to the p equals to 5 to the q or equals to 10 to the r, express r in terms of p and q. Okay, so basically we have this. Okay, I'll just write the symbols over here for notation sake. So this basically means that r is expected to be an expression in terms of p and q, where p and q can either be adding, minus, times, or dividing together. You can also have power, but yeah, that also counts, but yes. Anyway, general idea is this. So and you see me put a star there because I took this out from like an SPM trial question, and it's kinda hard. If you go through the workbook and you flip in to the back of the practice questions that I didn't ask you guys to do, it's in there. But obviously because it's in there, I didn't put it in the MIE. But you will still need to, you will keep this worksheet for like SPM usage, because everything is in this worksheet is also part of the syllabus. Okay? So even though it's not in the upcoming first mid-year exam, is the main exam that you'll be taking years later, okay, next year basically. So yeah, better to keep this as a future usable resource. Okay. Okay, so anyway, since you are given this thing and to express r in terms of p and q, I'll just copy the star over. Okay. So let's do this. What you want to do is you want to find expressions in terms of you want to find expressions for p, q, and r respectively first. Then you can proceed with everything else. So what we can do is as follows. You see your pen is just sitting there, right? And then what you can do is as follows. Because you want r in terms of p and q, so we want r to be, we want expressions for r. Okay, so what we can do is as follows. Three things are equal, which means that I can split them into different equations. So what I can have is your 2 to the p is equal to 10 to the r. Again, I must include r over here because then it will be simpler to talk about. But since both things are equal to 10 to the r, I'll just start with p first. So 2 to the p equals to 10 to the r. What I can do is I can add log to both sides. Because if you want to bring out the unknown and you are in power form, if you want to bring out the power like this, the easiest way to bring out the power is to separate it out, is to turn it into logarithm, turn it into log form. Okay. So now what we can do, we can bring the powers to the front. So we get p log 2 equals to r log 10. And then since because of this particular action, when I put log on both sides, I can actually put any log I want. Therefore, I can basically just move the places. I can basically just set it to be log 10. And why do I want it to be log 10? Because then this log 10 over here can just disappear and become 1, and that's good for me because it is easier to work with. Yeah, so getting rid of one log is easier to work with. So since this goes to 1 directly, I can basically just rearrange it and just write r equals to p times log base 2. Log base 2 is a certain number. We know we can calculate it, but I'll just leave it there for now. Okay. Next, my 5 to the q is equal to 10 to the r. Okay. Yeah. So my 5 to the q is equal to 10 to the r as well. So I can do the same thing. Both sides add log. Bring to the front. Log base 10 equals to 1. So I have r equals to q log 5. Okay. So these two things happen to be equal, right? So it is basically it. Because I don't have the answers right now, but if you look at it, right, it says p and q, but it doesn't say that you cannot have two answers. So, and if you want to find a way to write r in terms of both p and q, like like what the question implies, after trying it, you feel like it's not really possible per se because you just can't. Oh, it's supposed to be q log 5. You can't really do that, right? Now, what you can do is this. So, if you want to forcefully gabong them together, you can. So, from the r and q expression, you can bring your q to the other side. So you basically just write r over q equals to log 5. We'll be replacing the log. We'll be trying to get rid of the log in this case. So I'll talk about how. 5 is 5. 5 is also 5 is 5, so you just put this here. Why do we want this? If I expand from my first expression over here and I want to get rid of the log and exchange it in terms of q, right? I can. 2 is m divided by 2 is what divided by what? That we can use over here. 10 divided by 2, 10 divided by 5. Therefore, I can write log bracket 10 over 5. Yeah, so I can do this. Then my p bracket log 10 minus 5. I can basically do that. Then what happens next is, wait, let me actually just use another color because it is effectively a different part already. I'll also use a different color for this because this is effectively the second half of the question. So let's say I want to get rid of the log, I can. So I do this by finding an expression for log 5 first, and then I replace my 2 with 10 over 5, and then since division within one single log turns into subtraction, I can write out log 10 minus log 5. Since the base of my log is originally already base 10, log 10 thus becomes 1. Log 5, I can bring my r over q into play like this. And then Now what I can do is I can just multiply it. I can just rearrange my terms. So this is P minus PR over Q. Okay. The terms that have R I can bring over to the other side. So I basically would write arrow R plus PR over Q equals to P. Factorize R out. 1 plus P over Q equals to P. Therefore, to save space, I'll put in here and then I'll change to red color. My R can be written as P divide 1 plus P over Q. And so combine this together to become a single fraction. You can try to further simplify it a little bit actually. So this will be that. One I can turn. I want to make it into one single fraction. I will have to change the denominator. So 1 equals to Q over Q. So I get Q plus P over Q. And then if I want to write it, I think it's easier to actually write it using this. So it's easier for you to see. And how is this easier to see? Because if you are dividing a fraction, you can, as always, turn it in, no matter what you're dividing with, no matter what you're dividing by, as long as you turn division into multiplication, you will have to flip the second term. Therefore, P minus divide times into times, flip the entire thing over, so I get P times Q over Q plus P. Then my P is a large number, I multiply with a fraction, I multiply on top of the fraction, therefore I will get PQ over Q plus P, or if you want to make it look good, you can write P plus Q. So you can actually write R in terms of P and Q only without any logs, and it is possible because we can do it this way and the question is designed properly. Well, that's how it's supposed to be done. So because it explicitly says express R in terms of P and Q, although usually the first half, the answer, the results you get from the first half, the blue color ones are acceptable in a general way, but if we want to get rid of the logs, we can actually do so because the question is designed properly. So we can get rid of the 2 by changing it into 10 over 5. Log 10 we have an expression is just equals to 1. Log 5 we also have an expression that doesn't rely on the logs themselves, which is R over Q that we got from the outside. Therefore, this is what we can do. Yes, thumbs up. Therefore, this will be the answer. Okay, and you can see why I put the star over there now. If you try to go through the practice section of the workbook, which you don't have to, I would just say that which you do not have to for this NYE. You do not have to go through the very hard portion of workbook, the practice portion. If you go through that, you will see harder questions than this, and some of those are not very easy. That's why I will say that you can just leave it until SPM, okay, or MI or YYE lah. YYE will also be me obviously, but we will see what happens when we get there. Okay, anyway, move on. Question 6. Okay. Let me just see. I want to. I don't know how to try. There will be. Okay, let's see. Oh yeah, she's off. We can do. Let's do a bit. Let me type. Oh, I didn't put it in. So it's not necessarily extreme background with what is okay. Okay. Any of the I'm not sure. Doesn't really matter this one. So we structure it. Get there. Okay, next question 6. Question 6. Also a start question. As you can see, the given expression isn't really that easy. So, but this is basically another solving. It's basically question 3 type question. So it's basically the type of index equation where you have to solve it, and in this case you see there's a 4, there's a 2 over there, right? And 4 you can write it as 2 square, so you already have the 2x and x double index equation. Therefore this is definitely a quadratic. Yeah, so the equation we start with is 15 plus 4 to the x equals to 2 to the x plus 3. Again, you want to simplify this as much as you can. So first you rearrange. 4 is 2 square. Okay, we do this because we can. Then 2 times 6 is x minus your 2 to the x plus 3 equals to plus 15 equals to cosine. You can turn this, you can swap 2 and x to write x 2 to the x bracket square, 2 to the x square. You can do this to the x bracket and then the entire thing square. So then you want to split your 2 to the x out, so you see your x plus 3 over there. Again, if you see that and you can't do anything about it, just split it. So x and 3 turns into x plus 3 turns into 2 and 2 to the x times 2 to the 3 plus 15. Okay. So we continue. So see, this is again another quadratic. So let me just change colors. So I think it's purple. So let 2 to the x equals to y. You will get y squared minus 2 to the power of 3 is 8. You should remember this by now. It should be instinct. If you go through enough questions, this should be instinct for you already. Okay, then again, you can factorize this. Usually the ones given can be factorized. If they can't, then you will have to use a calculator for this, which will be quite troublesome. So we try to include questions that don't really test on this, because it's supposed to be about the modifying of the powers, not the solving part. The solving part is secondary. So 8, 15, what you can do, 15 you have 5 and 8, 5 and 3, 5 and 3, right? So 5, 3. 5 plus 3 equals to 8. Okay, we need an 8. So this is what we will be going for. We will be going for 5 and 3. So we put the 5, we put the 3. So you see our middle term over there, that minus 8 is minus, right? Is minus. So the only way you can produce minus in terms with addition is just plus minus or minus minus, right? And since your 15 over here has a plus sign attached to it, your factors must be both the same sign. So it's either plus plus or minus minus. Since we need to have a minus 8 over there, we will be going for minus minus, because minus 5 minus 3 we get minus 8. Okay, and therefore since this is complete, this will be the answer. You can verify yourself that this is indeed the case. So you'll get y equals to 5 or y equals to 3. Okay. And then as you can see here, now we want to find x, because the question says that alpha and beta be the roots for this equation, and your alpha and beta, since it's the roots, it is obviously in terms of x, and then it wants you to find the value of alpha plus beta. So we want to find the x's first. Okay. Yeah, so because yeah, the x's are the roots. So back to blue color, we have 2 to the x equals to 5 or 2 to the x equals to 3. This is different from the previous equations in the part 1 of the recording, question 3. You can see that neither 5 or 3, although they are both positive, which means they have corresponding answers, but none of them are powers of 2. So what this means is that we want to convert this into log form and use your calculator to go through the calculations. So how do you do this? You put a log over here. Your base go you want this will be an expression for your power. In this case is equal to x. So your x will be equal to the log. So your x will be equal to the log. So your log in this case, your original base is here. Your base number over here is 2. So this 2 will become your base of the log, and then the 5 will go here. Okay. Then goes to the other case. This will be equal to your x equals to your log base 2 3. Okay, so just plug these 2 into your calculator and you should get the answer. So wait, but before that we don't. Why? Because you see it wants us to find the value of alpha plus beta, which means it wants us to find the sum of the two roots. Therefore, at the end, what you can do is that your sum of your roots, which is basically SOR, okay, can be written as these two roots adding together. And because both of them are the same base, you can combine them together, turning plus into multiply. So 5 times 3 like this. Okay. Then therefore, instead of calculating 2 numbers, you can now only need to calculate 1. Even yet, it is actually perfectly fine to leave your answer like this. Because again, I just want to see you know how to do it. Knowing how to put this into a calculator isn't really that important unless the question specifically says 4 decimal places. Right? So this would be 3.90689 round up to get 69. Some of you who have asked me before would have already known this, but yeah, I'll just mention it here. 4 decimal places, okay? 4 decimal places whenever possible. Okay. Cool. Ooh. Interesting. I do not know who joined the live stream. Okay. They did not left any. Okay. So next. Okay, question 7. So next would be search. So indexes is just this. The main things you need to know are how to do simplification. So 2 things that are multiplying, they become plus, add your power together. 2 things that are doing division, you subtract their powers. Okay, you subtract their powers. Then depending on what the question wants, the way you simplify them can be either combining them, usually simplification, or you split them out, where it will usually be if you need to split them out, it will usually be the case of solving equations. Yeah, so when you solve equations or when you want to simplify stuff that has like added command powers, you just split. When you split, if it is a fraction, then you can split it. Then you can cancel your 3 to the n or 4 to the n or 2 to the n out. But and then you leave with the numbers. But if it's something to cancel out, then you just leave it as is. Okay, half an hour, good enough. Okay, next. Question 7. Question 7 enters the portion for search, and evaluating values like these are quite important. they are quite important. So what we want to do is that these are quite important. So what you want to do is to know how to do them, obviously. So let's go through this a bit. Okay, 7a. Evaluating this kind of fractions where your denominator has square root, you always want to find a way to get rid of the square root. Yeah. So the easiest way to get rid of the square roots are to superficially impose squares on them. Okay. So for example, in this case, I have f2 minus 1 over f3 minus f2 minus not f2, sorry. Square root 2 minus 1 over square root 3 minus square root 2. So how do you want to do this? The easiest way to impose squares on this kind of fractions is you want to multiply by the same thing at the bottom but changing the sign. So minus with plus, plus with minus. Why does this work? Please attempt it on your own, then you'll get what I mean. To know how this works, you can try verify yourself that using either both pluses or both minus will not get us the answer we want, but using 1 minus 1 plus to get us the result we want, which is basically posing squares on both of the terms without any other extra terms that would distract us from our original goal. Okay. So this is a no, this is a no, but this is a yes. You can verify yourself that this is indeed the case. Anyway, let's continue. So do this. So you will get your bottom would just your bottom will just directly be a squared minus b squared. So if you know this already, you can just skip the steps, right? So your bottom will just be a squared minus b squared. So your first term is square root of 3, so this will get a square. Your middle term is minus, and then your other term will also get a square, so square root of 2 squared. This thing you want to divide, this thing is at the bottom. For the top, it is basically both of your expressions added together, multiplied together. So original one is square root 2 minus 1. Your new one that you're multiplying this by is square root 3 plus square root 2. Okay, so you basically get these two things together lah. Okay, so just multiply. And then how do you and then as some of you might have asked in the past, how do you even multiply them together? And to that I say you just expand them as usual. So what will happen is as follows. Square root 2, so you do the expression, so you do the expansion, and if some of you remember, it is what you say in Mandarin, 一三一四二三二四. So you basically just go through the expression like that, 1 to 3, 1 to 4, 2 to 3, 2 to 4. Okay, so how is it written like out? Square root 2, 1 to 3, square root 2 times square root 6, you get square root 2 times square root 3. Square root and square root can multiply together, you get one single square root, and then it says the numbers inside you multiply together, 2 times 3 is 6. Okay, next, square root 2 times square root 2, you get plus square root 2 squared. Plus plus is plus. And again, I want to mention that your plus over here is attached, or your plus or minus, your plus and minus are attached to the numbers behind, to that number behind it. Okay, please understand this. If you move the number with the same sign, the sign isn't going to change, right? I remember I did mention this during the live streams. Okay, if you move the terms around on the same side, which in this case we only have one right hand side, the sign wouldn't change because the sign is attached to your number. Okay, so your plus is attached to both square root 2 case. It's not minus. It's not minus. Okay, so Square root 2 times square root 2, you get square root 2 square. Next, negative 1 times the bracket. Negative 1 times square root of 3, you get minus square root of 3. Negative 1 times square root of 2, square root 2, you get minus square root 2. This will be over by, this will be divided by, your bottom is 3. So, square and square root cancel out, you get one single 3. Square root and square cancel out, you get one single 2. So, your bottom is 3 minus 2. 3 minus 2 is equal to 1. And if it's 1, you don't, if it's 1 at the bottom of a fraction, you don't even need to write it out because it is already assumed to be 1 no matter what. Therefore, at the next step, you can just get rid of your denominator, your bottom unnumbered, just get rid of it. You can ignore that. So now we get square root 6. Square root 2 and 2, square root 2 square and square root cancel each other. So you get plus 2 minus 3 minus 2. Now, can this be further combined? No. Your square root 3 and square root 2, although they definitely can multiply to become square root 6 under normal circumstances, over here we are doing minus. If your roots are doing add or minus and their number inside is different, you can't do anything about it. Just let it stay there. Therefore, after going through all this ending string of numbers would be your final answer because you can't do anything about it. You cannot simplify this anymore. So square root 6 plus 2 minus square root 3 minus square root 2. And the issue is, if you try to directly put the question into the calculator, it will return you a decimal point, which is not what the question wants. The question wants to see you be able to do denominator rationalization manually, which is what we are doing over here. We want to be able to do it manually because that is what the exam and the question tests you about, the ability to do calculations manually, even though it might look very tedious. Okay. So we have 7a. Next, 7b. Okay, 7b, same thing. This is 4 minus square root 5 at the bottom, 3 on the top. So same thing, we want to get rid of the square root. So we just multiply by the plus and negative numbers. So in this case, what color did I use for this? So same thing, multiply by your negative is plus is negative. Okay, so negative is plus, I multiply by 4 over 5, 4 plus square root 5, then my top will do the same as well, so I will basically get this. Then proceed to calculations. This will get you for your bottom, your top is just your number multiplied by your new extra bracket with the square root. Your bottom will always be first thing square minus second thing square. First thing square is 4 square minus second thing square is square root 5 square. Okay, next turn. Yeah, I can leave this for, I can leave the other side for C. Okay. Next, top 3, bottom first, because after we do bottom, we will get something interesting. Bottom first, your bottom is for 4 square minus square root 5 square. 4 square is 16. Square root 5 square is how much? You cancel the thing out. So you cancel your square and your square root out, you will get a 5. Okay. So this basically just gives us 11. And you want to check, 16 minus 5, you get 11. Is 11 divisible by 3? Well, you can double check with your calculator, and the answer is, it's basically simple logic. The answer is no, because 11 is not multiple of 3. Therefore, since you can simplify your 3, just multiply inside lah. Okay. So 3 times 4, 12. 3 times plus 3 times square root 5, 3 times 3 square root 5, 3 square root 5. So there's nothing you can do with this since it cannot be factorized by 11. So this is your answer. Anything else you can do? Okay, then A, E. Next, C we have 6 plus square root 2 over 6 minus square root 2. Okay. So this same thing, you multiply both top and bottom by the same value, by the same reverse value. So we multiply 6 plus square root 2 on top, both top and bottom. Your top will get 6 plus square root 2 square because both are the exact same expression. Your bottom will get 6 square minus square root 2 square. Again, square and square root cancel each other out, so we can preemptively do this. Please do not do this for the top portion because you cannot do that. If you are doing addition in the middle, you will have to do this more carefully. Yes. Okay, so continue. Okay, so 6 square minus 2. 6 square is 36. 36 minus 2 get 34. Your top is, how do you calculate it? If you are not sure, please manually split it into two brackets, so and then do it manually, so you can at least be sure that you can definitely get the answer. Yeah, this way. Okay, you can definitely get the answer by doing it manually. Okay, back to this. So anyway, if I skip through the process, you can verify this yourself. Expanding a square means I get my first thing square, 6 square, plus my second thing square, is square root 2 square, plus a middle term. So in this case, it will be 2 times first times second. 2 times 6, 12. 12 times square root 2, 12 square root 2. And then else you can do, this will be your answer. Okay. So then you can do this with the answer. This will look like that. Then you can further simplify, so let's go through the simplification process. The 6 square is 36. Square root 2 square, again you can cancel out both the square and square root, so you just get a plus 2. 36 plus 2 is 38. So you get 38 plus 12 square root 2 over 34. Okay, so we see, can this be simplified? Yeah, because both all three terms are divisible by 2. So what you can do is, I can write this into, let's put it aside because it's only like a simplification answer. It doesn't really matter. You get this and you're good enough with it actually. And these are questions, they aren't very involved. I don't think the one in the exam paper is that involved. And you basically just get 3 marks. So I mean, obviously it's out of 80, but 3 marks is better than nothing. So please try to go through everything that you can. Okay. So 38, 12 and 34 are all divisible by 2. If we try to increase it to 4, it just doesn't work anymore because both 38 and 34 are not divisible by 4. And then you try to go up, none of them are divisible by any numbers anymore. So we will stop at 2. Everything divided by 2. I use another color to determine, they will talk about this. Everything we divide by 2, you get 38 is 19, 12 is 6, 37 is, and 34 is 17. Therefore, you get 19 plus 6 square root 2 over 17. Nothing else you can do, this is your answer. Okay, let me just double check. You are doing good. Let me just check that. Okay. Okay, that should be fine. Okay, we can do it. Okay. Okay. Right. Okay, seems to be looking good. Um, using trans aspect on out, but well, it's still okay because it's for my voice, so that's good. Hey, let me key something. Okay. Right. Okay. Okay. Okay, so back to continue. So question D. Let me just extend this for the covers everything that the sequencing will look for. Okay, D F B minus 2 5 over 1 plus square root 2. Same thing, you want to get rid of the square root at the bottom. In this essay you just add the corresponding complement, you can say that. Yeah, call it a complement. So minus, we multiply with the plus complement. So now we are starting with plus, we add with the minus. Yeah, we add with the minus complement. Okay, so you will get 1 minus square root 2 over 1 minus square root 2. So let's multiply this entire thing, both top and bottom. So you will get, the top is the two, again it's the two things multiplying together, so you want to get two brackets, do expansion later on. Your bottom will be your first thing squared. 1 squared is just one number, just write it for yeah, for showing it is the case. For square root of 2 and then minus square root of 2 squared, so you get this thing. Top, you denominator, the two brackets on top, again expand as usual. I'll just go through the calculation without saying too much, so we can quicken the process, and I can go through the other more important ones. This is mostly familiar to you. If you are unsure, please pause and ponder. Right? And you should have already went through the questions before you watch the videos. Okay. I mean, like you also can just watch this on your own, but yeah, not really supposed to per se. Prepare to that. Okay, so now you have when you just go through the calculations, you get this. Okay, if you're not sure, just do the expansion carefully. So just do it carefully. 1 3 1 4 2 3 2 4. Okay. Your -1 is at the bottom. You want to simplify it. So what you can do is basically just multiply your entire thing on top by a minus. Okay. Okay, back to this. So minus will go, your minus we can go either top or bottom. I can choose it to go to the top, and so my denominator just becomes 1, and then it can just disappear, so my entire thing just turns into one single line without the fraction. And then you can just multiply the negative sign into the entire thing. Minus 3 plus minus becomes plus, plus becomes minus. You can leave it this way, nothing else you can do. This is the answer. A E E. Yeah, this way. Okay, so 1 plus square root 5 over square root 4 minus square root 6 plus 2. Since there's a plus 2 over there, you want to deal with it first. And okay, you can choose to either leave it there or you want to deal with it first also. So there are two ways. Dealing with it first means you need to turn your 2 into a fraction by giving it the same denominator. So you want to use this and multiply square root 4 minus square root 6 square root 4 minus square root 6 on the top. Then you will combine it into the fraction that only you do the, and then only you do the normal, and then you only deal with the square roots at the denominator. But that will make the expansion very hard to do. So extension at the top will be very hard to do because you have 4 terms combining with 2 terms, and that's quite troublesome. So what we want to do instead is we want to put the 2 aside, put the plus 2 aside, and we deal with the main fraction first. Okay. So your plus 2 just sits here a bit farther than my fraction, and then because of what I want to write here is again the rules for dealing with it. So your bottom will multiply with the positive counterpart, a positive complement, so plus square root 4 plus square root 6. And then your top will multiply the exact same thing, square root 4 plus square root 6. Okay, so can I tell you we should change this right there? Yeah. Okay, continue. So okay. So wait, let me just do a step. Yeah. Okay, there we go. So now we proceed. See? So your bottom it is okay, your top is still the 2 put together. Your bottom is first thing square minus second thing square. Okay. your plus 2 is still there to the split there. Your bottom is 4 minus 6. Again, I'll go through the calculation without talking too much. Simplify whenever possible. Bring negative to top. Combine the plus 2 by giving a denominator of 2, so 2 becomes 4 over 2, and incorporate it into the denominator alongside, and do it together with the step that where you multiply the negative sign into the bracket. 4 minus 2 is 2. Anything else? This is your answer. For square roots, quite convoluted, but still the same way. Again, first with minus 2. This first multiplied by minus. These sort of questions are very procedural, and if you understand how to do it, and you know how the steps, and you know that the steps is just the same every single question all the time. You know that the steps are the same every single time, then you're able to do it every single time. Procedural questions are very easy to score. You can also choose to memorize the steps, and it will still turn out the same. $56 is 4 times 1 4 14. Okay, again, verify whenever possible. Okay, square root 10 minus 2 square root 10, 1 minus 2 negative 1. 14 minus square root 14 plus 4 square root 14, 4 minus 4 plus 1 plus 3. Negative bring to the top. Get. Multiply inside. Nef pause. Nef pause nef. Anything else you can do? Answer. Okay, GH, G and H are raised at So you see two fractions, right? So question G would mirror latihan 8, I think. 2 to 4. Latihan 8 question, the second last question 5, I think, yeah. No, question 5. And then H would mirror question 6. So if you observe the denominators for G, see that it's square root 6 minus 2, square root 6 plus 2. Both of them are already complements of each other. So what you can do is you can just cross multiply, turn them into the same. You can just cross multiply, turn them into the same denominator, turn them into one fraction by making them the same denominator. So just multiply. You can just multiply like that. But for H, one is not the complement of the other. One is 7 and 2, one is 3 and 1. So yeah, if you combine them together, you get nothing. So you are forced to do it separately, basically. The calculations are quite tedious, but if you go through them again, it is quite a procedure type of question. If you manage to go through them without issue, then the marks are just given to you straight away. A1, okay. Okay, continue. So next page. Okay. For this one you can combine. So what I mean is that first fraction you multiply by square root 6 plus 2, square root 6 plus 2. Second fraction you multiply by square root 6 minus 2, square root 6 minus 2. Okay. So what you get is you have two fractions having the same denominator. So you will just get square root 6 square minus 2 square in the middle of the entire thing. I'll draw this long because it is indeed this long. First is 1 plus square root 5 times square root 6. In the middle is minus 2. This called. Expand. I'll go through without. Wait a minute. So 60 is 6 times 10, but it is also 4 times 6. 4 become 2 square, bring up become 2. If you are unsure where everything should go, you can write the square roots in sequence of in form formula, which is descending order. 2 minus 2. We also have by 4. If everything has a coefficient 2, you can simplify, but in this case you can't. So just leave it as is. Because you have 2, you do have 2, 2, 2, 2, but this 30 doesn't have a 2, so you can't do anything about it. H. H you have to do it separately no matter what. So the first thing you multiply the negative count. The second fraction will start with the negative counterpart, so you multiply with the positive. I should count for the complement. It's not really counterpart, it's coefficient. A square minus B square. A square minus B square. A square minus B square. So let's do that. I gotta watch out for volume. But I thought to solve with between infinite sentences, it just cuts me off, so I'm not sure is there a way to make this mic more sensitive. I'm not sure is there a way to make this mic more sensitive, but it should be fine as long as I talk loud enough. Hey, A square minus B square is this. So I can hear myself better. I can make sure the feedback has no issue. So I'm listening to my feedback, so I'm making sure that my watch is good. Oh wait, I made a mistake at G actually. 2 squared is 4. 6 minus 4 is 2. But again, no 2 over there, so cannot see it. Yeah. Yeah. Two is good. This one is 1. 2 minus 1 is 1. 2 minus 1 is 1. Minus 3 minus 1. 2 minus 1, 2. Usually you want to combine, so cross multiply. First fraction times 2 times 2, second fraction times 3 times 3. Yeah, if I am this close to the mic, then you can give me. Okay, so I guess 6 overall. Your first thing multiply by 2. I'll do it on the other side. I still have space away. Never mind. Oh, but that means step away. 3 times this over 6. Yeah, just multiply everything into the corresponding brackets. This is okay. Let's do it here instead. By the way, you actually can do this if you do not have. As long as you make sure that it's obvious this is the entire thing bunched on top of that line instead of not. As long as you make sure that you are very clear, you make it very clear that the things that is bunched on top is the denominator, you can do this in your writings. You can do this in like you finish. ratio 3 from 1 over 6. Signifiable? No. Answer. Okay. Not signifiable, so this is the answer. Anything else? Hey. Question 7 done. We use entire page. I mean, voila, this kind of question. I think I give 2 or 4 marks. Yeah, I think I gave 3 or 4 marks for this type of question. So, you can again, very procedural type of question. If you know the procedure, then you can go through it. Okay, next question 8. Question 8 is the type of equation that features square root. So what you want to do with this type of question a little bit different, because it doesn't rely on the power and log kind of formation. Because usually if you have went through questions 2 and 3, you will know that to find unknown powers, you want to turn it into log, and then from log, and then you have learned in class for latihan 18, where latihan 19 and 20, where if you want to start from log and find the unknown inside the log, you can turn it into power form. So equations are none of that. So equations require you to know that the best way and the only effective way to get rid of the square roots is to make it a square. And how do you impose squares onto square roots? With how the equation is structured. Since it's an equation, you have left side and right side, right? You can square both sides. If you want to get rid of the square root on the left hand side, you square it, so you just square the entire thing. But since it is an equation, you want to repeat this action on your other side as well. So you square one side, you square the other side. I think I put 2 of this in the exam, 1 in paper 1, 1 in paper 2. So the paper 1 is compulsory. So just know okay. Continue. Okay, so 8a1, 8a. Okay, so square root x plus 1 equals to 3. Most simplest case, what you want to do with this, if you want to get rid of the square root, make it a square. Square left side. Okay. Okay lah. Question number house but okay. Continue. So next, you want to get rid of the square root, you want to square. If you square left hand side, you square left with you square right hand side as well. So that's why you get this particular formation over here. After this, just go through the calculations and you should be able to get answers. So you don't really have to care what's inside the square root actually. So anyhow, if you have square root, you want to get rid of it, you square, and then you square and square root, this cancel each other out no matter what is inside. So square and square root cancel, gone. X plus square root gone, x plus 1 come out. 3 square is 9. X equals to 9, 1 plus 1, bring over minus 1, and minus 1, 8. Done. You can pull it back inside to check your answers. You will see it's correct. So yeah, there might be certain cases where we need to do this because sometimes you get 2 answers and you can get skeptical. So it is obviously okay to get skeptical about the answers, so you want to double check them. And usually what we will see in the following sub questions is you might run into one answer out of the two that is just incorrect, that doesn't fit the question at all, so you have to check. Okay, same scenario, square both sides square root disappear. Algebra autopilot. Okay. Okay, now here we encounter in question C. Here we encounter the one without a square root has an x. So it doesn't matter. You square both sides. So left hand side square root 1 over x. Right hand side you square it. You just expand it. Yeah, expand it. So rearrange to form a rearrange into the normal ax squared plus bx plus c format. So plus 4 minus 4, x minus x minus, and yeah, x squared plus 5x plus 5. If you put this into a calculator, you will see that there is an answer. Yeah, I'm just trying to mentally calculate this. Oh yeah, there's an answer actually. So again, virtual calculations. My calculator and the calculator on my hand cannot go through this automatically because it's a simpler model. So I'll just do it by hand. You can verify that this is the answer by your own. Okay, so you get just turn into decimals for easy calculation, right? So -5 plus maybe this -5 plus the root 5 over. Just can use in my calculator right now. So your x is equal to -1.38 19 1 up to 1, or I can just modify this -33.6.80. Okay, so what you want to do is you want to double check. So let's just put this into the original equation given the questions. Double check whether this actually fit the bill or not. First, x is 4 minus 1.382. This gives me this much, and then 3 minus 1.382. 1.618, yeah, same answer. Next, square root 4 minus 3.618, 0.618, and then I take 3 to minus 3.618. Oops, so you see, if I put this one into my equation, my left hand side I will get positive number because that's what my theory is supposed to give me. It cannot give me negative numbers if I type it into the calculator. So you get 0.618. But if I put this into my right hand side, which is 3 minus this number, I will get a negative 0.618. So since this happens, your left and right hand side are not equal to each other when your x is equal to this number. Therefore, you basically just directly reject out. So, which means this is your only answer. Okay. donkey. Okay, so you see this one, same thing. Square root, bring over to the other side. You want to square both sides, and if you square over here, if you square both sides in this particular configuration, there will be a lot of issues because we use small square roots, which is not what we want. Therefore, and you have to do double job. So it'll be easier to just bring the square root to the other side first. Is equal to cosine. So then you can just bring to the other side. You can just bring to the other side. So you get 3 plus x equals to square root 3. So x. Okay. So since this is the case, atau both sides. B plus x squared equal to x squared. And back. Nine. Okay, this is where things get a bit weird. Yeah, you get plus 9 from this, and because it's plus 9, if you go through b squared minus 4ac, okay, it's negative. So what this means is that your x has no solution. Yeah, it just basically means that your x has no solution. So you can basically, what you can write here is basically, you can just write out you going through the calculation for b squared minus 4ac, because you just want to double check because it looks weird, and in it is weird because this is negative, which means that your x has no real solutions. Therefore, this particular equation has no real solution. That's basically it. Yeah, that's basically it. So I will then wait. No real solutions. Writing this out is necessary because you have something to justify to me that, okay, why you know that this has no difference, because you use b squared minus 4ac to check. Plugging this into the calculator and getting a solution in terms of I, you can also use that as a justification, but only do that if you understand what I truly is. Okay, I appears because your square root has a negative number, and negative numbers inside square roots, they just coined it to be in terms of I, where I is square root of negative 1. If you look up the term imaginary numbers, or you ask ChatGPT what it is, it will most likely reply you something akin to this as an answer, which is basically what it is. So unless you understand what I is, I prefer you not to copy the output from the calculator into the answer sheet as your x. I prefer you not to do that. Okay, but in any case, okay. draw line E. I'll finish until I'll finish the entirety of question 8, then we end this portion. Yeah. Then I'll split it into another live stream. So logarithms will be another live stream. We have 4 questions left. E 4 minus x square the root equals x plus 1. Same thing, square root both sides. Again, it's a very procedure type of question. So if you manage to go through all of this without much issue, then you are definitely ready for whatever that's to come in MIE ready. Again, I modeled the exam after my worksheets. I modeled the worksheets after my exams. After the exam. Yeah. After the exam paper. This one has an answer. 3 and 1. You can't factorize this, but there's an answer. So x is equal to b is minus b is 1. Good. No. Pilot. Okay, so same thing, you get 2 answers. You can write them in terms of decimal. Okay. 2 answers. Same thing. You want to double check whether either of the answers need to be rejected or not. And for this particular question, it is easy to check because my right hand side is x plus 1, and the main rule for square roots are that you cannot have negative numbers inside the square roots, then it will become I, then you have no use for that. So what we want to do is we can just show it in our right hand side over there. When x is 1.3028, you add 1 is still positive, so this one is good. Okay, so why I say this, because your second one, your x is minus 2.3. Minus 2.3 plus 1 is still minus. When it's still minus, you get minus 1.3. A negative minus number inside square root, you cannot, because you get I. Therefore, we just reject it outright. We will reject it outright because this solution violates the general rules for square roots. General rules for square roots, which is negative number inside square root is no, because this gives us negative number inside square root, so we reject it. Next. Now, this one is a bit tedious, but since there isn't really any real way to do it, you want to square root both sides first no matter what, because you are faced with 3 square roots. Okay, so okay, 1.5. Cool. Okay. Yeah, we can definitely finish within 2 hours for this portion. I'll open up a new portion. Okay. square both sides. So I'll just write it out carefully so you get an idea of what's going on. First thing square plus second thing square minus 2 times both things. Equals to, and I'll just use that space. 4 plus 3x. Evaluate. Both have square root, multiply is by square root. Rearrange terms. X plus x 2x, 4 minus 3. Bring these two things over, minus 4 minus 3. Square root bring over 8. Bracket x plus 4. You can just expand. You can expand it inside over here. Minus 1 plus 4. Yeah. Yeah. And do arithmetic. 2 minus 3 minus 1. 3 minus 4. Left hand side no square root, right hand side still got square root, we square both sides. Minus 1 minus x minus 1 is square root. This might be hard to see, but if you expand it and do it manually, you will get this as well. Because there's 2 minuses. So they just cancel each other. Out when you go through the calculations. So you get plus 2x as your middle term. Square on both 2 and square root. So you disappear, 2 squared is 4. 4 multiply inside. Rearrange terms. You get this much. Okay. 3 and 17, you can't really do anything with this. Yeah, you can get 10 with this. So because both are prime numbers, you don't really have that many combinations. So this should be your answer. Yeah. So again, find x. So to directly see whether your equation has a solution or not, if either A or C, either one of them is a or not, either one of them is negative, then you definitely have an answer. In this case, I can definitely say that this has 2 real and different solutions because of this. You can go through it that way. Bit easy. 4 times 17. 4 times 17 minus become plus. This was 100, 304. Square root 304 be written as let's do my one. This can be written as 4 square root 19. You can verify this by putting this into your calculator, or you can do it manually. Simplify. Negative 5 plus minus square root 1 minus 2 19. Again, x gets 2 answers. again we want to check. This should be plugged in into the original equation, not everything, not after the squared version, not anything else. And again, the easiest thing to check for is just whether your number inside your square root will turn negative or not. For 3.7178 positive, the only minus term is the x minus in the middle over there. The only minus term is your x minus 1 over here in the middle. If this doesn't become negative, then you're good already. 3 minus 1 is still positive, obviously, so this answer is accepted. But the other answer, negative 13.7178, put inside, you get negative number. Even if you put within this s plus 4, you also get a negative number anyway, along with this actually. So because of that, not accepted lah. Yeah, it is rejected directly because negative number inside square root is a no. Negative number inside the square root is a no. Okay. Okay, done. So question 7, question F. You can see comparatively it is quite long because you are required to do two squares on both sides action. You are required to do 2 of square both sides. Yeah. Okay, last 2 for this portion. If you are still using the old version of the worksheet, I modified this question because putting the plus x in the middle actually makes it very tedious to solve. If you square both sides, you get x squared. But you still need to square again because you have 2 square roots. So you square it again, you get x to the power of 4, which is solvable, you get x to the power of 4, which is not solvable within our current means. It's not solvable within our current means. So yeah, it is not solvable within our current means. So what will we doing? This way I got rid of the x. This way I got rid. Same thing, square both sides. There isn't really a better configuration per se to square both sides with. No matter how you rearrange it, you still need to square both sides. So, and one doesn't really give you the advantage of it. Yeah, for this case maybe, because it is actually better to square only to do only one. To square with only one square root within the mix. You on one side, even though you in this case you have a minus 3 attached to it. But it is still marginally better. This is 3 square by the way, but it is still marginally better to do it with only one square. Good. Then you can mitigate the action of getting a square inside the square. There's a quadratic inside the square root. Then it doesn't look pretty lah. So I'm just checking whether I was correct or not. Rearrange. Rearrange. 2 plus 9 plus 2. Both sides. And change this rearrange into 13 minus x for easier manipulation, so you don't get confused. As much. um the question this one definitely got answer, because although even though that none of your A and C are negative, none of your neither A nor C are negative, your B square is so huge enough that it will definitely be larger than your 4AC. Yeah, 104 square. Okay, nice. Okay. Yeah. The number inside the square is 104952. This is what happens when your questions are. This is what happens when the question designed with the answer in mind. Like you see, these are the questions that come out, and there's also related questions that you see if you go for SPM textbooks, reference books, prior papers, past exam papers, question compilations. There are a lot of these kind of questions in there, but the main difference between the SPM questions themselves and the questions here are that the answers in the SPM are actually a bit prettier because they are designed with the answer in mind. My worksheets, you see answers like, because the worksheets themselves are the questions themselves aren't really designed with aren't really designed with the answer in mind. That's why you can have very large numbers. Yeah, that's why you can have very large numbers like these. Typing 10452 square root into the calculator doesn't simplify it for you. So you will have to simplify yourself by dividing it by 2 repeatedly, because only over here you only need 2 to simplify it out. So it will give you this will give you dividing it by 2 twice will get you 2613, which means 4 times 2613 is equal to 10452. And because of this, 4 is 2 square. 2 square going out from jump out from square root becomes 2. 2613, you don't have to care about it. It will just stay inside there. If you continue to simplify it, let me see. Okay, let me just. Okay, I can't. Eight, 7, 1. What can I do with this? 9. Oh, I can't even get by 3. 7. Oh, I can't. We said 7, 1 a prime. Oh no, it's 13. 13 times 67. But both 13 and 67 is a prime anyway, so it doesn't matter. I'll just keep it there. I'll just keep it there. It doesn't matter. We don't need to go through the entire. Everything divided by 2. So 104 divided by 2 is 52. 2 divided by 2 is 1. But the denominator is also gone because it says 1. So this, you can see this answer. Same thing. Divide. So 52 plus 2613. Let's go 2613. So x equals to 103.1175 or 0.8825. Yeah, it is that much. 2613 is like it's like 50 something. 50, it's not 51, but it's 50 something. 50 something. I think it's 51. 51 point something. Yeah. Okay, so again, you want to put these two things into your original equation to double check whether there are any issue, right? Oh wait, I haven't. Okay, I haven't sent that file to the second. Okay, so same thing. You want to see. Okay, in this case, you can't really check for negative numbers. Wait, you can. Can you? Okay, I'm not sure. Never mind. You just go through calculations. No, in this case, we cannot. X minus 2 will return positive values for both. Anyway, so yeah. Oh, okay. 2 plus 2 times 107. That 1.4341. Right. Oh, what do you know? The 103.1157 doesn't work. Apparently, you get different answers for both sides. Okay, then let's check the 0.8825. Oh, okay. Wait, let me double check the entire thing. I already answers both. Seven. The 0.8825 also gave me different answers. So let me just double check. 6. Yeah. 6 squared is and 13. Yeah. 13 squared is 160. Oh, I see the issue. Hey, 36 times 2 is 72. Ish. This is supposed to be 98. No wonder I was like, wait, what? No. no way both answers are incorrect. There should be only one that's incorrect and then one that's correct. Whoa, what? Okay. So this is pure luck. But apparently by rectifying my mistake, apparently this actually a factorizable equation. This is by pure luck, by the way, but apparently it is like that. So just get x is 97 or x equals to 1. Okay, we can get rid of all of that. We can get rid of all of that. Okay. 2 hours. Okay. Then again we can do double checking. Okay, this is by pure luck. I did not design this question to become like that. 2 plus 2 times 7, 3 11, 3 times 27, minus 2, 17. Okay, so 97 is out. 1, 2 plus 2, 2 minus 3. Oh no. Both answers are incorrect. Why is this the case? If I swap actually if I swap my negative 3 and the other square root, it'll be correct, by the way. Both answers will be correct. But as it stands, right? No, plus 1 will be correct. But as it stands, wait, 2 minus 1. Both answers will be correct only if we allow our square roots to output negative numbers, but obviously we do not allow that. So let me just verify this with Wolfram Alpha real quick. Okay. I need to end this like views. Oh. But this is holding me up and I can't go after it. So give me a moment. Okay, let's see what Wolfram Alpha says. What solutions exist? Yeah. Oh, okay. Yeah, no solutions exist. Okay. We have successfully verified that no solutions exist by using computer. So that will be the answer. Both answers do not work. Therefore, there are no real solutions. There apparently are also no imaginary solutions because cases do not intersect. But that's for another day. So no real solutions. Again, this is what happens when you make questions on the fly. Okay, will the same thing happen to this? We will see. M 16. Fourteen squares. 2 times 4. We range to simplify everything divided by 4. Okay, this one is factorizable. 2 brackets. X and X. 5, you get 2 and 7. 7 minus 2. Minus 7 plus 2. Minus 7x plus 2x minus 7 plus 2 plus minus 5. Okay, for this one again, we can double check. X equals to 7. X equals to 7. 7 inside becomes 7 plus 2, which is 9. Which is right hand side, I get 7 minus 7. Minus 3, I get minus 3. Okay, left side not equal to right side. This one reject. X minus 2. Left hand side minus 2 plus 2 kosong. Right hand side 7 minus plus 2 7 plus 7 minus 7 plus 2 3 minus 3 kosong. This one is answer. Therefore x equals to -2. Okay, that one was easy enough because it didn't give me too much trouble. Okay. It's better to write out the answers after you reject the other one. It's better to write out the accepted answer. Okay, these two will be enough. This one no solution. One answer, no solution. Reject one answer. Okay. Okay, so that's that for now. Again, square root equation or third equation of formula, I have like 2. Paper 1 got 1, paper 2 got 1. So just go through this. And again, it's very procedural. Whatever you see, rearrange it such that one side got square root, one side no square root. If you have 2 square root, then put 2 on both sides. If you have 3 square root, prepare for tedious bookings because you have to square twice. But if you don't have, yeah, so usually you have to square twice. Even if it's like G and H, even if you only have 2 square root, right? unless it's like E, you don't have anything additional adding to it. If you like G or H, even though you only have 2 square roots, you still have to square both sides. And that's why you see the workings are quite long. I think I have one of these in paper 2, like the section C where you can select the questions. Yeah, but otherwise, if you have 1 square root, move it, rearrange it such that one side got square root, one side no square root, square both sides. If you have 2 square root, square both sides. One side, 1 square root, square both sides. If you have 3 square root, you have to square twice, square both sides again, and then square both sides. Yeah. So that is it for now. I will end it here. So I will see you in the next one when we talk about dog. Okay. Done.